Now this is a binomial distribution because the plants are one thing or the other, and we're picking from a certain number of plants. So for part 1 it's binomial, n is 8, and my probability of getting red is half. So I want the probability that I get more than 6, in other words, probability that I get 7, or probability that I get 8 that produce red. 7, 8c7 times p, which is half the power 7 times 1 take p, plus 8c8 half the 8. When I type that in to 3 sig figs, 0.0352. Now part 2 is still binomial. This time my n is 22, and it's the same variety, so p is still half. To write 0.5 or half, it doesn't matter. It's worth making a note of what the distribution is because that can get you marks. Part A, equal blue, equal red. In other words, the probability that I get 11. So that is 22C11 times P the 11 times 1 minus P the 11. 3 sig figs gives me an answer of 0.168. Part B, find the probability that the number of plants that produce blue is greater than the number that produce red. So I want my blue to be more than 11. Now if I had, I've got my statistics tables in the formula book, and I could use the tables for this type of question, but unfortunately n equals 22 doesn't feature in our books, so we're going to have to go the long way round. What we're looking for is that the probability of 12 or 13 or 14 and so on up to probability that we get 22 blues. It is very long-winded, it's just a case of typing it in really carefully. You will get an answer to 3 sig figs, 0.416.